Okay, we are on quarter 2, week 8, day 1, and we are going to find the quotient. All right, so we're going to look here, 12. All we're going to have to do is make that 12 over 1, and now that's a fraction. So what are we going to do? Since we're dividing fractions, we're going to keep, change, and flip. Okay, so we're going to keep the 12 over 1. We're going to change the division sign to a multiplication sign and flip, or do the multiplicative inverse of 2 over 5, which makes it 5 over 2. All right, so can we cross-reduce anything with 1 and 5? No, we can't do anything with 1 and 5. No number other than 1 goes into 1 and 5. How about 12 and 2? Yes, 2 goes into 12 and 2. 2 goes into 2 one time. 2 goes into 12 6 times. And we just multiply across. Again, this is just saving us the need to simplify later by cross-reducing before we multiply. So 6 times 5 is 30. 1 times 1 is 1. And so our answer is 30. All right, that's our answer to 12 divided by 2/5. Okay, now we need to find the difference. Well, that means we're subtracting. There it is. There's the subtraction sign. We do have decimals. If we're adding or subtracting with numbers have decimals, we have to line them up. Yes, we do. So we have 764.7 minus, okay, we have to have the decimals lined up, so we'll have to go, the 45 would have to go there, 0.39. All right, now we can subtract. We'll put the 0 here. Can't take away 9 from nothing, so we're going to have to subtract, or reduce. Not reduce. We're going to have to borrow from the 7 and make it a 6, make this a 10. 10 minus 9 is 1. 6 minus 3 is 3. 4 minus 5. Can't do that, borrowing from the 6. All right, so we have 14 minus 5, which is 9. 5 minus 4, which is 1, and 7. Bring down the decimal. The answer is 719.31, or 719 and 31 hundredths. Because there's 2 places to the right of the decimal here. Okay, that's the difference between those 2 numbers. Find the missing number of each unit rate. Well, again, I can go ahead and accept the fact that they're calling it a unit rate because we are going to a fraction that has a 1 in it, okay, or a ratio. All right, so since we're talking about rates, we got to go from 15 down to a 1. Well, what would you divide into 15 to get 1? Well, once again, that's pretty straightforward. We're going to divide 15 into 15 to get 1. Right? So, if we divide 15 into 15 to get 1, we're going to have to do the same thing with the denominator. Okay, so 45 divided by 15. Well, 15 and 15 is 30, so another 15 is 45. So it would take 3 15s to get to 45. So 45 divided by 15 is 3. So that's the number for that one. All right, how do we get from 9 down to 1? Well, again, pretty straightforward. We're going to have to divide by 9. 9 goes into 9 one time. All right, so then we're going to have to do the same thing with 27. 27 divided by 9 is, well, that happens to be 3 also. Okay, so that simplifies down to 1/3. So really what this is saying is since both of them can go down to 1/3 as their unit rate, every single one of these is an equivalent ratio to each other because they're all they're all able to be scaled up from the unit rate of 1/3. So anyway, that's the answer for both of those. And we'll move on to the next one. How many milliliters are there in 4.5 liters? Okay, so there's actually 1,000 milliliters in 1 liter. So to find out how much it is in 4.5 liters, we're just going to put a 4.5 over here. Okay, and what does it take to get from 1 to 4.5? Well, again, we're doing some pretty easy math here. Just do times 4.5. Right? So then, here's the thing. We have to just do the same thing with the part of the ratio on the top. So we have 4.5. Okay, so 1,000 times 4.5 just means, remember, if you're multiplying by a number that has zeros, or it's a base 10 number, like 10, 100, 1000, you just move the decimal however many zeros there are. Since there's 3 zeros, you just take 4.5 and you move it over 3 places. Okay, so that's going to end up being 4,500 milliliters. All right, there's our answer for that one, 4,500 milliliters. What is the value of 3x squared plus 5x? When, well, this is nice, they're actually giving us the value of the variable x. All right, so that's going to be easy enough. We're just going to put that in wherever there's an x. So we have 3x squared would be 3 squared plus 5 times x. Well, x is 3. All right, so we have to do the squared, the exponent first. So 3 squared is not 3 times 2. It is 3 times 3, okay? 3 times itself. So that is 9. So we have 3 times 9 plus 5 times 3. All right, so now we just know we have to do the multiplication before we can add them together. So what is 3 times 9? 3 times 9 is 27. 5 times 3 is 15. Okay, so then to find this answer, we just do 27 plus 15, and that will give us 42. Okay, that's our answer once we plug 3 in for x. What is the value of y? So I kind of did this down here a little bit lower just to kind of give me some space. Circle the correct answer. So we do have 2 possible answers, and probably the easiest thing to do is just plug in 7 for y and do 23 times 7. See if it's 115. Or you can plug in 5 for y and see if it's 23 times 5 and see if that's 115. Okay, but I also want to show you, since we're solving one-step equations, how you would do that. So once again, we have 23, if we're looking up here on top. We have 23y equals 115. So we're going to divide both sides by 23. And why are we dividing? Well, 23 and y right next to each other means multiplication. And I always say that you're going to do the opposite operation to solve. Okay, so 23 goes into 23 one time. So we're just left with 1y on this side of the equal sign. Okay, so that's all we have there. So now we have the equal sign. And then we have 115 divided by 23. So that's not a real easy number to do, but the answer is 5. Okay, so because 5 times 3 is 15, and then you're going to carry the 1, and 5 times 2 is 10, so it's going to end up being 115, or 115. So we know by solving it with a one-step equation that y equals 5. Okay, so there's our answer for that one. And if we would plug 5 in for here, we would just do 23 times 5, which would give you 115. So there's a couple different ways to do that one. This is the direction you're going in the future, so kind of try to learn the process or steps for that, because that'll help you quite a bit coming up here. All right, so let's move on to the next one. Okay, for 8 days, Jackie made beaded bracelets. When he was done, he had 96 bracelets. Write an equation to express how many bracelets Jackie made each day. So she made 80 beaded bracelets, 8 days. For 8 days, Jackie made beaded bracelets. Okay, for 8 days, she made the bracelets, a total of 96 bracelets. Okay. All right, so we know that 96 is the total. We know that she did the bracelets for 8 days. So to see how many she did per day, it's going to be 8 times something. Okay, let's just make it D, I guess, will equal 96. So write an expression, or write an equation to express how many bracelets Jackie made each day. That's the equation. Okay, if you want to solve it, you would divide 8 from both sides. So you would just do 96 divided by 8, and that would be 12. So D would equal 12, but they're actually not asking that, but we can solve it anyway. So D equals 12, but this is the equation that they're asking for. Solve for G. Okay, so again, they're kind of keeping the numbers pretty simple just to kind of get the point across. So I'm going to solve it the algebraic way. You could just try numbers that you think are reasonable, stick them in for G, and do 72 minus what number will give you 36, and then kind of figure it that way. But I'm going to do the algebraic way. So we have a, excuse me, we have a negative G on this side. So we're going to add G to both sides. All right, because I don't want a negative G to work with. That just makes things messy. All right, so if we have a negative G and a positive G, that ends up being 0, right? Because no matter what G is, G could be 10, so a positive 10 and a negative 10 will be 0. A G could be 1,000, a positive 1,000, a negative 1,000 would be 0. So that's just gone now. So the only thing left on this side is the 72 equals 36G, or 36 plus G. All right, and then I always say that you need to use the opposite operation to solve for this. Okay, so to use the opposite operation of addition, we're going to subtract. So we're subtracting 36 minus 36 over here too. All right, so a positive 36 and a negative 36 end up being nothing. So the only thing we have left on this side is G, and then we have 72 minus 36, and that gives us 36. Okay, so there's our answer. G is equal to 36. And then you can go test it, put it up here on the top here, and put in 36 for G. 27 minus 36 is 36. All right, so that's our answer. G equals 36. You could actually do it this way first as well. You could put G first. G equals 36 or 36 equals G. Same thing. So let's move on to the next one. Okay, so here's our new concept for this week. It says write the inequality, which means it's not going to be equal. It's going to be greater than or less than this number line represents. Well, I mean, I guess it could be equal also. But we're also going to have things that are unequal. All right, so the big thing about this lesson is looking at this number line. What do you notice about that circle? Is it colored in or is it not colored in? So if I move that out of the way, you can see that it is not colored in. Okay, so it's just this simple. If it's not colored in, you're not going to include that number. So it's not going to be equal to 3. It's either going to be greater than or less than 3. Okay, if it was actually colored in like this, okay, if that was colored in, then you would include 3, and then you would use one of these here, greater than or equal to, or less than or equal to, because we're going to include the 3 in that situation. Okay, but it's not like that. It is not colored in, so it's going to have to be one of these, either greater than 3 or less than 3. So whenever I'm creating an inequality, I just usually use X. And I know that the number we're dealing with is the number 3, because that's the one we're graphing. So look at the numbers that the arrow is covering. It's covering numbers that are to the right of 3. So are those numbers bigger than 3, or are they less than 3? Well, 4 is bigger than 3, 5 is bigger than 3, and every number above that is bigger than 3. So whatever X is going to be a number up in this direction. So X is greater than 3. Okay, that's all there is to number lines. So just remember whether it's colored in or not makes a difference, and then which direction it goes. Okay, if it was faced this direction and not this direction, okay, then X would be less than 3. Okay, but that is not the case. Okay, so X is greater than 3. All right, that's the new concept. Should be pretty easy, and hopefully you got it from here forward. All right, I guess that's the last one for today.